this is Surya, Assistant Professor from the Department of CSE in St. Joseph Institute of Technology. So today we are going to discuss about K-means algorithm. So K-means algorithm comes under your AI subject, right? So what is mean by K-means clustering algorithm? Before going into the K-means, let me tell you what is mean by clustering. So clustering in the sense, if we are grouping some points, so if the data points is consist of 5 or 6, so I am going to group these into one cluster and this into one cluster. For example, let me tell you, let us assume the coins, okay, 1 rupee coin, 2 rupee coin, 3 rupee coin. So even 1 rupee coins all comes under cluster 1 and 2 rupee coins all comes under cluster 2. So likewise we have to cluster those data points. So for that we are using K-means algorithm. So using this K-means algorithm we are going to cluster the data points. So it comes under unsupervised learning algorithm. Once again, what is mean by unsupervised learning? So unsupervised learning is nothing but unlabeled data. Okay, your data will not be labeled, so it is unlabeled data. And another thing is they will be giving the set of items, certain futures and values for those futures. They will give all these data, just we are going to cluster those data. That is the one point. So how we are going to cluster? So we can use any of this distance formula. We can use Euclidean distance, Manhattan distance, Hamming distance or cosine distance as a measurement. So we can use any of this distance and we can calculate the distance point, then we can cluster the data points. So this is your flow chart, how your data points is going to work. So first we have to start the clustering. So initially you have to choose the number of clusters you need. For example, as I said, we can go with the coins itself. Okay. So if I am having 3 or 4 coins like 1 rupee coin, 2 rupee coin or 3 or 5 rupees coins. So these are the 3 coins. So how many clusters I need? I need 3 clusters, right? Because 1 rupee all comes under 1 cluster. 2 rupee all comes under second cluster. And 5 rupees will comes under the third cluster. So we need 3 K points. So like that you have to choose the K value. Whether you want 3 cluster or 4 cluster depends on your points. You have to decide this. Okay. After deciding this, we have to choose the centroid. Centroid in the sense you have to choose some center values. For example, let me tell you, we'll go with this line. So here I am having some set of clusters as like this. Okay. Set of cluster like this. So what I have to do is, you have to choose some centroid value. Suppose my K value is 3, then I have to choose 3 K values, right? So you choose 3 centroid values. This is purely depends on you. You can choose any of your cluster value, any of the centroid points. It's purely depends on you. In case if in your question paper if they are mentioning these are your center points, then you have to choose those centroid points. Else you can choose your choice. Okay. So I am taking this as one centroid and this is one and this is the third one. Okay. Anything you can choose. So depends on this only you have to calculate the distance to the objects to the centroid. What it means? So each and every one called as an object. So you have to calculate the distance between these 2 values. Then you have to calculate the distance between these 2 values. These 2 values means this is my first centroid. You have to calculate the distance between my first point to the first centroid. Then you have to calculate the distance between my first point to the second centroid. Again you have to calculate the distance between first centroid to the first point to the third centroid. This is how you have to calculate the distances. Okay. So now after calculating those distance, grouping based on minimum distances. You have to group the data based on the minimum distance. So you have calculated some values for this and some values for this and another some value for this. Maybe let me tell you this is 5, 6 and 7. So what you have to do, you have to group based on the minimum distance. So how you have to group? So my minimum distance is 5. So this cluster belongs to, this first data point belongs to cluster 1. This is how you have to calculate. Okay. Then you have to move on to the next. No object move group. Suppose if the cluster points is not equal, okay, we are going to find cluster and new cluster. If those 2 points are not equal, then again the step is going to be repeat. Again you have to find the centroid, the new centroids. Again you have to follow up the same step. So when we are getting the new cluster without matching anything, so we are getting the new cluster, so we'll end the program. Okay, this is how your k-means algorithm will work on. Now we'll go with the example. Okay, now we are going to solve this example. Okay, so I have given some data points like A1, A2, A3, B1, B2, B3 and C1, C2. These are the data points. So as I said, you will get the data points in the question itself. They will be providing data points, all those things. But only what we are going to do is we are just going to cluster the data points. So which cluster belongs to which data points? That is what the question is. Okay. So these are the data points. First step, what I said, after the flow chart, after choosing the k values. So you have to choose the k values. As you have A, B and C, I am going to choose 3 as your k value. So k equal to 3. So this is the second step. What's your third step? You have to choose the initial centroids. So you have to choose initial centroid. It is purely depends on you. In case if they are giving the question, if they are giving what are those centroid points in the question paper, then you have to follow that questions. Okay. Else you can choose your own centroids. So I am going to choose my own centroid here. I am going to choose 3 centroid points. As your k value is 3, we have to choose 3 centroid points. So I am taking A1 is a 1 centroid, B1 is a 1 centroid, the another one is C1. Okay. So my data points are A1, so 2, 10. And the second one is B1 5, 8 and the third one is C1 1, 2. So these are the 3 centroid values what I have chosen. Okay. So now what we are going to do, we are going to apply your k-means algorithm using Euclidean distance. So this is the formula of Euclidean distance. What's the formula? So d of P1, P2 equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the formula. So now what we have to do, you have to create a table. So the table consists of data points, distance too. So the data points is nothing but you have to write all the data points, that is A1 value, A2 value, A3 value, B1, B2, B3, C1 and C2 values. So I have written A1 is 2, 10. So I have written 2, 10. So here A2 is 2, 5. So you have to write 2, 5. So A3 is 8, 4. You have to write 8, 4. As like this, you have to fill your data points. Now this is your data points. So the next one is distance 2. So what I said, you have to find the distance between the centroid value and your data points, right? So what are my centroid values? These 3 are my centroids. So I have made this columns. So these 3 are my centroids. 2, 10, 5, 8, which means A1 is 2, 10, so 2, 10. So the next one B1 is 5, 8, so 5, 8 and C1 is 1, 2. So I have written 1, 2 here. So these are your 3 centroid. Now you have to find the distance between these two things. Okay, distance between your data points and the centroid values. For that we are using your Euclidean data points. Let me tell you the example. So the first step, the first one you have to find. So for that what you have to do, what is your x2 here and x1? So consider these as your x1 and this is your y1 and this is your x2 and this is your y2. Till solving this part. If you are going with the next part, this becomes x2 and y2. Okay. So let me solve this. So what you have to do, x2, what is the x2 value here? x2 is 2 minus, what is the x1? x1 is also 2. So 2 minus 2 the whole square plus y2 minus y1. So what is the value of y2? y2 is 10. What is the value of y1? y1 is also 10. So what you have to do? 10 minus 10 the whole square. What you will be getting? You will be getting 0. Always you write with 2 digits. 2-digit values, okay, like which means after the decimal point you have to use 2 digits, okay, always use the decimal value, okay. This is the first one answer. So this is that is what I have written here, 0.00. Now we have to find the second one, okay, for A2. So what is the value? Again square root of what it is, what is the value of x2 here? So x2 is again 2, x1 is 2. So 2 minus 2 the whole square plus what is the value of y2? y2 is 10, but the value of y1 will be changed. Here the value of y1 is 5 now, okay. So 10 minus 5 the whole square. So what you will be getting? You you will be getting the answer is 5. Because 10 minus 5 it's going to be 5. 5 square 25. So if you are taking out from the square root, you will be getting 5 is the answer. This is for the second one. Now again we will do for the third step. What is the value here? So 2 minus 8 the whole square plus 10 minus 4 the whole square. Right? So 2 minus 8, because your x2 is 2, now your x1 becomes 8, and x2 y2 is 10, your x2 y1 becomes 4. Okay, so what I have to do, 2 minus 8 the whole square plus 10 minus 4 the whole square, you will be getting the answer is 8.49. Okay, is it clear? So we'll solve the other centroid values. Yeah, now we will find the distance of the next value. So the next value is 2 minus 5 the whole square plus 10 minus 8 the whole square. What you will be getting? You will be getting 3.61. So like this we have to finish all the steps. Okay, after completing till this, what you have to do, next step, while we are moving on to the next step, we have to change this x2 value. Now this becomes your x2 and this becomes your y2. Okay, so this is your x2 and that is your y2. So to solve that, what you have to do, what is the x2 value? Your x2 value is 5, right? 5 minus x1. So x1 and y1 remains the same till all the 3 steps. But your values will be changed when these 3 centroid values will be changed. You have to compare with the centroid 1, centroid 2 and centroid 3. That's why we are changing those values, right? So 5 minus 2. Okay, 5 minus 2 the whole square plus what is your y2 now? Y2 is 8, right? So 8 minus 10 the whole square. Here y1 is 10. So 8 minus 10 the whole square. What you will be getting? You will be getting 3.61. Okay, this is how you have to solve your problem. Once this part is over, next you have to change this x2 and y2 as like this. So the third centroid is your x2 and y2. Okay, now you compare these two values. Again you have to calculate the same. So what you have to calculate? You have to calculate for 1 minus 2 the whole square plus 2 minus 10 the whole square. We will be getting 8.06. Okay, so we have calculated all these things. I have written the answers for all those things. The next step, what you have to do, as in the flow chart, what I said, you have to choose the minimum value, right? So minimum value, make this as cluster 1, cluster 2 and this is your cluster 3. Okay, now you have to define your cluster. What you have to define, which is your minimum value, that is your cluster point. So check with these 3 things. So which is your minimum value? C1 is minimum because C1 is 0.00. So this one belongs to cluster 1. Okay, this one belongs to cluster 1. You can write it as a 1. I'll just simply write as 1. Okay, because this is cluster belongs to first cluster, so I am just writing as a 1. Okay, now we have to compare these 3 points. So what is your cluster point now? In this 3, this is the small value, right? This is your smallest value, so your cluster is 3 because it is in the third cluster. Okay, next we have to compare this 3. What's your cluster? Your cluster is 2. Here in this, your cluster is again 2, and this your cluster is 2. In this data point also your cluster is 2. What about this? Here it is 3 and in the last one it is 2. So this is your cluster. So first cluster we have found. What we have to do for the new cluster? You have to find the new cluster to compare the 2 cluster points. So you have to find new cluster. So what is the work of new cluster? So now we are going to find the new cluster. For that we have to choose the new centroid points. You are not supposed to use the same centroid values. We are going to take the new centroid values. For that we are going to calculate the average of each clusters. Okay. For example, let me tell you, one belongs to only one cluster. Cluster 1 belongs to only one data point, right? So only one for first cluster. So what we have to write? The first data point, the first centroid point is same. There's no need to change your centroid point, okay, because it is only one, so you have to write as it is. Now we'll move on to the second. If you are going to choose the second cluster, if you see 1, 2, 3, 4, 5, we have 5, 2. Okay, so what you have to do, you are going to take the average of these values. Okay, let me tell you how to take the average. So B1, okay, B1 belongs to, how I am going to take the average. First you add these values, which means x values. So x values 8 plus 5 plus 7 plus 6 plus 4. So these all belongs to second cluster, right? So I am going to add those values. So what you will be getting, 8 plus 5 plus 7 plus 6 plus 4 divided by, what is the meaning of average? So if you are adding 5 numbers, then you have to divisible with 5, right? So you have to calculate the average. This is for x value. Similarly, you have to take for the y. So y, again, what is the y values? So 4 plus 8 plus 5 plus 4 plus 9. Okay, so I am taking 4 plus 8 plus 5 plus 4 plus 9 divided by again 5. Okay, you are taking the average value. Now you have to write down what is the average value. Just calculate these things. So I will be getting 10, 20, 30. Yeah, 30 by 5, comma. Here also it's going to be 9, 10, 20. Again it is also 30. So 30 by 5. So 30 by 5 means you will be writing P1 equal to 6, 6. So this is your new cluster of B1. We have found the cluster for a new cluster of A1. This is your new cluster of B1. Next what we have to do? We have to find it for C1. Alright? For C1 what you have to do? So you have to check how many trees. So you have 2 3 points. So you have to take the average for those 2 points alone. Okay? So I am taking average of 2 plus 1 divided by 2. Okay, comma, and the y value, again you have to take the y value, 5 plus 2 divided by 2. What you will be getting? You will be getting 3 by 2, comma, 7 by 2. So what will be the final answer? 1.5, comma, 3.5. So this is your C1. So these are my new centroid points. Okay, the another 3 centroid points. I have found 3 centroid points. So now what we have to do? Again we have to do the same procedure using these 3 centroid points. So we have to change these 3 centroid points into these new centroid points. Okay, let me change and I'll explain. Okay, now I have changed the new centroid values. See, I have changed here. So this is your centroid 1, right? 2, 10, and your centroid 2 is 6, 6, and the third value is 1.5, 3.5. So I have changed those data points. Okay, I have changed those centroids. Okay, now you have to, again what you have to do, you have to find the distance between these 2 points. Okay, distance between your data points and the new centroid values. Okay, so again the same formula you have to use, nothing else. You are going to use the same formula entire problem. Only the new thing is you have to find the clusters. That is what the thing is. Okay, so again I have to use the same formula. So what is your x1? What is your x2? 2. So x1 is again 2 to the whole square minus plus what is your y2? 10 minus 10 the whole square. So again your value will be 0.00. So I have written 0.00. The same way, mostly this answer will be the same, right? So these will be changed because you have received a new data point. This is your new centroid value 6, 6. So these values will be changed. This is the same centroid value 2, 10 in the first step. So here also you are using 2, 10. So these value remains constant. Not constant. This at this part it will remain same. Okay. So if you are moving on to the next, so I'm telling this first one alone. So what I have to do? You have to write x2. So 6 minus 2 the whole square plus again 6 minus 10 the whole square. So you will be getting the answer is 5.6. So the same way you have to find all these values. This will be over. Okay. So the next thing what we have to do, you have to find the cluster. Okay. But the one thing you have to follow is in the second table also you have to write your previous cluster. So this previous cluster remains same. What you are going to do, you are going to find the new cluster value. This is your new cluster points. Okay. How you are going to find the new cluster point? As I said, from these 3 data points, which is the smallest minimum value. So that is your cluster. So which is the smallest one? The first one is smallest. So this is belongs to first cluster. So from this, which is the smallest, the third one is smallest. So this is belongs to third cluster. From these 3 data points, which is the smallest, second one is smallest. So this belongs to second cluster. In the same way, you have to fill up all this. So this is also belongs to second, and this is belongs to second, and this is also 2. And what about this? This belongs to 3, and this cluster is belongs to 1. So we have found the new cluster. So now what we have to check? We have to compare your old cluster with your new cluster. Okay. So these both are same, right? So this is okay. What about this? These 2 are same. So this is also okay. These 2 also correct. So this is okay. These 2 points also correct. Fine. So this is also correct. Okay. This is correct. Fine. This is correct. Fine. But you have found the error here. So this data point is different, and this centroid belongs to different centroid, right? This cluster is belongs to different centroid value. So this is belongs to second cluster, and this is belongs to first cluster. You have the variation, right? So what you have to do, if you found the variations, again you have to find the new cluster using new centroid values. Okay. So what you have to do, now you are going to find the new centroid values using these data points, using these clusters. Okay. Using these clusters, you have to take the average now. So let me take the average so that you will understand. So now you check, you have 2 cluster 1, right? So in the previous one you have only 1 cluster. So what you have written, you have wrote the A1 as it is, but here you have 2 points, right? So the first one and the last one is belongs to first cluster. So what you have to do, take the average for the first one and the last one. So that is your A1 value. So A1 belongs to what you have to do, you have to take the average of 2 plus what is this value, 2 plus 4 divided by 2, comma, and this is 10 plus 9 divided by 2. Okay, what you will be getting? So your A1 value is 6 by 2, comma 19 by 2. So you have to write your data point as A1 value. So A1 becomes 3, okay. So A1 becomes 3, 9.5. Right? So this is your A1 value. Okay, new centroid value. This is your new A1 centroid value. So again, what you have to do, you have to find for B1. Check how many clusters we have found for B. So almost we have 1, 2, 3, 4 points we have. So again, we have to take the average of those 4 values. What is the average of those 4 values? So 8 plus 5 plus 7 plus 6, right? Divided by 4. See here you have 8 plus 5 plus 7 plus 6. These all belongs to second cluster. So I am taking average of these 4 things. So 8 plus 5 plus 7 plus 6 divided by 4, comma, again for the y value we have to write 4 plus 8 plus 5 plus 4 divided by 4. Okay. Now you will get the B1 as 6.5, comma 5.25. This is your B1 value. Okay. Now we have to find for C1. So again we have found one new cluster, new centroid points. Now we have to go with the C1. So again check how many C points are there. You have two values comes under C, right? So you have to take the average of those 2 data points. Okay. So I am taking those 2 data points are 2 plus 1 divided by 2, comma, again y value is 5 plus 2 divided by 2. Okay. So then 3 by 2, comma 7 by 2. what you will be getting? You will be getting as 1.5 comma 3.5, right? This is your new new centroids. Now what I am going to do, I am going to change all these values into your new centroid, as well the cluster value. What it happens, this new cluster will comes to this side, okay? This points are not required, okay? In the new table, we are going to make this as your old cluster, because this is your last cluster what we have found. Now we are going to find again the new cluster, right? So this is the last cluster. This is going to come here, and we are going to find the new cluster, okay? Let me tell you. Okay, now we are started with the new cluster points. So this is my new cluster points: 3, 9.5, and 6.5, 5.25, 1.5, 3.5. So I have found all the data values. Okay, so this is the values for these distances between data points and your centroid value. I have found the distances what we have. And one more thing I want to tell you, see what I have done here, the cluster, what I have written, this cluster is last tabular column new cluster values. These are the last tabular column new cluster value. So now I am written this in the cluster format, okay, in this cluster line. Why? We have to find the new cluster for this table, okay? Again we have to find the new cluster. So how we are going to find the new cluster? The same way, you have to compare these 3 points, and you have to choose the minimum value, and that is your cluster. Okay, now see what is the minimum value of these 3. The first one is minimum value. So here this is the first one is minimum value, and from these 3 this is your minimum value, and from these 3 this is your minimum value. Here the first one is your minimum value. How about this? Here the second one is your minimum value, and in this the second one again is your minimum value. From these 3 points, the third one is your minimum value, and the last one is the first one is your minimum value. So I am going to write the minimum values. So first cluster, this is belongs to third cluster, and this is belongs to second cluster, and this is belongs to first cluster. Again this is second, third, and this is belongs to first cluster. Now what is the second step? What you have to do? You have to compare the 2 cluster points, your old cluster as well as the new cluster. So now you compare. So these 2 are same, and this is also same, this is also same, but here again we have the changes. What changes here? In the old cluster it is 2, and in your new cluster it is 1. So what you have to do again, obviously no need to check with the other points. Obviously if one cluster is having the changes, if even one cluster has some changes, you have to find the new centroid points, and again you have to find the new cluster. Okay, so obviously this is a wrong format, right? So what you have to do, again you have to find your new centroid values. How we are going to find the new centroid values? The same way, but with the new cluster data points. With using these points only, you have to find the new centroid value. So now check how many ones here. 1, 2, 3. So you take average of these 3 data points. So what is the first A1? So A1 is 2 plus, again so this one, right? 2 plus 5 plus 4, right? So 2 plus 5 plus 4 divided by 3, because if you are taking average it is divided by 3, comma. Now you have to take for y. Y is 10 plus 8 plus 9. So 10 plus 8 plus 9 divided by 3. Okay, what you will be getting? You will be getting A1 is 3.67, comma 9. Okay, this is your first centroid, first new centroid. Again I have found the new centroid value. Okay, now what we have to do for the second one? So the second one in the sense the B1, the new centroid point for the B1. How many 2 are here? Again we have 3 2's. So for these 3 data points, you have to take the average of these 3 data points. So what is the average? So average will be 8 plus 7 plus 6 divided by 3, comma. Again for the y values, 4 plus 5 plus 4, right? 4 plus 5 plus 4 divided by 3. So what you will be getting? The B1 is 7 comma 4.33. Okay, we will be getting this answer. The next one, C1. C1 again you have 2, right? 2, 3 are there. So what you have to take? You have to take average of those two values. So what will be getting? 2 plus 1 divided by 2, comma, and what is the y value? 5 plus 2, 5 plus 2 divided by 2. So the C1 value will be 1.5, comma 3.5. Okay, I have found the new cluster. So now what I have to do? The same thing, you have to change those cluster values. You have to change those cluster value, and you have to find out the points, right? You have to find out the data values. Okay, then you have to find the cluster. So now I'll write all these things and I'll tell you. Just pause the video and solve this problem by yourself, so that it will be easy. Just pause the video and solve the problem by yourself. Then play the video, you will find the answer what it is, whether your answer is matching with this. Okay. Okay, now we are going with the new centroid points. I have changed those values. See, this is your new centroid points, right? 3.679 and 7, 4.33, 1.5 and 3.5, right? So these are the new centroid points. As you see, this values will not change. It remains the same because the value of the centroid is same in the previous table, right? 1.5 and 3.5. So no need to calculate again. You can write as it is. For these two alone, you just do the calculation. If you want, I'll do with the different data points. Like for example, let me do with this points. Okay, for this points I'll do. So what you have to do? How you have to find the centroid value? Have you all remember? Because in the initial of the video I have told. So now we are going to calculate the distance. How you are going to calculate the Euclidean values? So x2 minus x1 the whole square plus y2 minus y1 the whole square. Now this will becomes as your x1 and becomes as x2 and your y2. This, as I said, it's always x1 and it's always y1. Okay, there is no change in this point. Okay, it's always x1 and y1. But here it will be changed, depends on your solution. Okay. Okay, now I'm taking this value. So what you have to do? 1.67 minus 3.67. Sorry, 3.67 minus 5 the whole square plus the y value 9 minus 8 the whole square. What you will be getting? You will be getting 1.67. This is how we have calculated the distance, right? So once this column is over, you just move the x2 and y2 into this value. So now this will becomes your x2 and this will becomes your y2. Again I am solving for the 5 and 8. So what is your x2? x2 is 7. So 7 minus 5 the whole square plus what's the next value? Your 4.33, right? 4.33 minus 8 the whole square. So you will be getting 4.18. So this is how you have to find your Euclidean distance. I hope you remember the Euclidean distance formula. Right? The same thing we have followed all the tabular column. Why we are doing again and again? You have to meet the two clusters in the same value. Like your cluster and new cluster becomes till it becomes same. You have to follow the same step again. You have to find the centroid again. You have to do all those things. Okay. So now let me tell you. Let me come with the last cluster. I hope this is your last cluster. Okay. So now you find the cluster point. This is the smallest minimum value. So the first one is minimum value. So it belongs to first cluster. In the second one, it belongs to third cluster. Here it belongs to second cluster. And here it belongs to first cluster. And these three values, it belongs to second cluster. Compare these three values and it is again belongs to second cluster. Compare these three value, it belongs to third cluster. From these three value, it belongs to first cluster, right? So now what we have to do, you have to compare these two things. You just compare, these both are same, again these are same, this is same, this is also same, and this is also quite same, this is same, again this is also same. So both the clusters are same. So now we are at the end of your problem. We are in the end of your problem. So why? Because your old cluster and new cluster remains same. Okay. So what you have to write? Now you have to write which all belongs to your cluster 1. So what all belongs to your cluster 1? Which data points are belongs to cluster 1? 2, 10 and 5 comma 8 or belongs to your cluster 1. So this is B1 and this is A1. Okay, this is belongs to your cluster 1, and what is your second cluster, and one more is also belongs to your cluster, that is 4 comma 9 is also belongs to your first cluster. And what about the second cluster? You have 3 values again for the second cluster. So 8 comma 4 and 7 comma 5 and 6 comma 4. These data points are belongs to your second cluster. How about the third cluster? The third cluster belongs to 2 data points, that is 2 comma 5 and 1 comma 2. These 2 points are belongs to your third cluster. Okay, this is your final output. So this is how your data you have to write. So till it meets same, you have to do the steps again and again. You have to take the average, again you have to find the centroid values. So after that only you have to finalize your centroid 1 and centroid 2 and centroid 3. Okay, this is the K-means algorithm. Thank you.